Okay, thank you very much. First, I would like to get some information from Amalia. How many students were registered? Amalia, are you?
Yes, I'm here. I was mute, sorry.
Mhm.
Well, we have 75 confirmed students. Here present, we have kind of 65, more or less. So we'll see if the rest of them are joining.
And how do you divide them, undergraduate, graduate, postdoc and stuff like that? Do you have it?
Yes, the majority of students, I don't have the exact numbers here. I can share them later on, but the majority of accepted students are PhD students. We have also young academics, young practitioners, and in just some cases, we also accepted the applications from undergraduates or master students because they showed some very solid experience and very solid interest in HPC and or artificial intelligence. So this
and geography wise?
Well, we have a nice balance, let's say, between Europe, many countries, many different regions in Europe, and also Asia. We have lots of Asian applicants from different countries, not only ASEAN countries, but also China, Japan. Well, we have a very nice balance in the applications.
Okay, good. Okay, so thank you very much.
Thank you.
So I'll start. Okay. Okay, so I'll start just in order to ease the atmosphere a little bit by doing some analogy of technology and where we are going in general by looking at sailing. How many guys, is everybody on mute, or I can talk with some of the students? Amalia.
Well, we recommended students to mute themselves by default unless the lecturers were inviting them to speak. So
okay.
whenever you want...
Okay, so I'm asking if anybody is out of the 65 students that are online, if anyone experienced sailing? I don't hear. So anyhow, so I'll start. Sailing basics, when you do a competition in sailing, usually the competition is working on a triangle, which one of the side of the triangle is trying to sail against the wind. So the wind is coming from top to bottom here. You try to reach the buoy as a first, and what you have to do whenever we are talking about sailing boat, in a sense, what you have to do is to tackle right and left and to reach the buoy. We call it a left wing for this boat, and the wind which is coming from the right, we call it the right wing. But anyhow, if the wind stay in the same direction, definitely it doesn't matter if you are on the left wing of the wind or on the right. At the end of the game, if the boats are identical and the team is identical, probably you'll reach more or less in the same time, and that's the basic concept. But if we go to the next foil, in which we see that the wind is changing, and many times during the sailing, the wind is changing. So if the wind change in the direction, in this direction, which in an angle which is alpha, that means that the second boat here, have a head start because it doesn't have to go, it can go directly to the buoy, while the boat who was the first at the beginning, because of the change of the direction of wind, can go so sharply towards the buoy and have to give up here about alpha in the direction, which means that he's getting kind of, he lost some of the position that he already has. So if you understand the concept here, then comes the next question that I'm asking for the last more than 10 years. So if there is a sailing competition, and this is kind of a quiz, and we like to stay and to get first to the buoy, and there are two boats, and the boats are identical, totally identical, the team is identical, and there is no relationship between the boats, meaning the first boat doesn't cover the wind of the second boat and so on. And the main question for the boat is, what is the strategy of the first boat and what is the strategy of the second boat? And there's a specific strategy in this case. So this is the question, if somebody can help me and give me an answer. Let's start with the second boat, which is a little bit easier. It's too early in the morning that everybody's asleep or what?
Uri, not every one of us is a sailor.
Okay. But,
I was
okay,
sailing,
but,
I was sailing until last week, but none of us is a sailor.
yeah, I just taught you, the basics of the sailing. Anyhow, so I'll continue here. And the strategy of the second boat will be not to follow all the time the first boat. The minute you follow the first boat and you are identical in all the characteristics, you'll stay second all the time. So the basic idea, if you are following, if you have a competition and you are following somebody, if you are the second, the only way to bypass the first one is to do at least one time to do different from the first. If you do exactly the same as the first, you'll stay second always. Now, if you know the answer for the second boat, what is the strategy of the first one?
The first one should do what the second does.
Exactly. Very good. So if the first one, thank you, if the first one will look backwards and actually look at the second boat, and the minute the second boat will turn, the first one will turn also, it will stay the first all the time. So the basic idea, by the way, for a long time, I was showing these foils here and there, and then I realized one time, even when I was at Intel or a little bit after, that the first boat is Intel and the second boat for a long time was AMD. And interestingly enough, many times when we had ideas at Intel inside in the group of researchers at Intel, management didn't accept many of the ideas, but the minute AMD did some change in their architecture, automatically Intel decided to follow it. Example was the memory controller on die, the graphics, the multi-core, and so on. And a few times I asked the management at Intel, and I think subconscious they work this way. They say, don't change if you don't need to, but if the second boat is doing something, maybe it is right. So my bottom line here, that if you are second, or in general, when you do something, you shouldn't follow. You should invent. And by the way, in many cases, when you are the first boat, try to do changes that the second boat doesn't anticipate. So that's in general, when we talk about strategy, where to go, what to do, what kind of research to do, always try not to follow everybody else. Try to be in an area in which not so many researchers are, and probably you'll be able to do something unique that others are not doing. Okay. So let's start our presentation today. I'm talking about the next challenge that I see, which is energy efficient approach to machine learning architecture. We'll talk a little bit about what's happening now in machine learning, but only the high level. But we believe, and I'll show you some of the numbers, that you must approach the problem of energy, because the amount of computing that we see in machine learning is rising dramatically. And if we want to take care of the energy, we'll have a problem. Here we are talking about the group. This is my group of students, which are all contributors to this presentation. And we are working, as I said, mainly on energy efficient approach, not only for machine learning, but also for a general purpose architecture. So let's since we'll have about 4 hours to be together, let's try to see what is the purpose of this meeting. First of all, to understand, I think the best and most important thing is to understand the change in the environment. The change in the environment will help us to understand where we are going, and also to use, and I'll show you later, some of the concepts that we actually use already in current architecture for the new field that we are getting into. And the new field we are getting, it's actually a new computer wave, and the neural net hardware architecture. We are approaching neural net in general, and we can't stop it. It's running really, really fast. And if you look at the number of papers that are published on neural net, is exponentially grow more than Moore's law, and very interesting. And that means that there are a lot of people there. Most of the papers that we see today are more at the algorithmic level, a little bit less in the architecture. And we will show some ideas that we research in my group. But the main thing that I'll try to initiate here is out-of-the-box thinking. And we'll see a couple of solutions that we proposed and published. Very interesting that the field is kind of, I will say, almost empty. And that means that the opportunity is there to do a lot of research and find new direction to reduce energy in machine learning environment. And probably the most important line here is actually to create a passion to drive new next step in neural net architecture. In general, I think that all of us, I prefer at least, to work with a lot of passion about the technology and find a new direction and enjoy it. That's the most important. Administration-wise, I'll try to cover the first part of the machine learning, or more the background and the beginning of machine learning concept by the first part, which will take about an hour and a half. and then we'll have a coffee break of about a half an hour. We'll see how the timing will go, or will let us continue. And then the last part of my presentation will be the research that we are doing on efficient machine learning architecture. Question till now? Okay. References. There's a lot of references. I sent the organization of the summer school the reference for you to read. The first one is the excellent book by Zien Joel Emmer the tutorial, which is an excellent tutorial. It's a book, and especially the second one. So these are the two very good background to get started if you didn't work on neural net architecture. It's pretty interesting. All the rest are some stuff that we did. With some of them I'll touch here and there during my presentation. So that's the reference. So the outline. So actually the class today will be divided to three, which is first of all, I'll talk about the environmental changes. Later, we'll talk about machine learning basics to the one that they're not aware or not didn't learn about machine learning. So architecture, and I'll show a couple of direction, very interesting direction. And then the last one will be efficient machine learning research that we are doing, and we'll try to conclude in a positive way. So that's where we are. And let's start with the first one. The environment changes, you can ignore it. It's a pretty huge shake that's happening in the last couple of years. Me as the one who